All right, everyone, this is Mr. Wyrick. I'm going to try to go through some of the stuff on this review with you just real quick. Triangle MRW has coordinates at -10, 6, -4, -1, and -9, 1. So -10, -6 should be down here like this. That'll be M. Point R, -4, -1 right here. And then point W is -9, +1. Here's W. So this is my triangle. Then it tells me to move this 7 units up. That's going to add 7 to all of these Y values, and 5 units to the right. That's going to add 5 to all of these X values. Write the resulting coordinates below, show the translation over here. So I'm just going to write them real quick. It's going to be -5, 1. Okay, so -5, 1. That would be M prime. Then we have 5 units to the right. That would be 1. 7 units up. That would be 6. So that's my R prime. And then my W prime, what is it? 5 units to the right of -9 is going to be -4. And then 7 units up from 1 is going to be 8. So -4, 8, and that would be my W prime. Nothing really changes about this one except where it's located. On the second one, MRJ, 4 units down, 3 units left. Again, not much there, just a translation. On this one, MSK, we are reflecting over the y-axis. Remember, when we reflect over the y-axis, it's going to go from x comma y to a -x comma y. The y value doesn't change when you reflect over the y-axis. The x value just becomes the opposite. So if you're at -3, 4, yeah, -3, 4 would be here. That would be M. Then we would go 1, 2, 3 to the y-axis, 1, 2, 3 on the other side. This would be M prime. We are reflecting across that. I don't know that I have time on this video to go through every single point, so I'm just kind of trying to give you an overview. Let's see, reflect the triangle over the x-axis. Remember, this one, x comma y, is going to change to, you keep the x the exact same, the y becomes the negative of what it was. So 3, 4 would be here. The reflection would be at 3, -4. So this is M, this is M prime. Okay, so that's kind of how we change that through there. Triangle MSD, we're going to rotate this one 90 degrees clockwise. Remember, clockwise is going to go like this, okay? It's going to be in the direction that the numbers go on the clock. I do still have the clock in the corner of my room, so not that big of a deal. -4 over 3 up is going to be this point right here. I can actually just physically rotate this 90 degrees to see where it would be, and it would be over 3 up 4. So this is my M over 3, 1, 2, 3, up 1, 2, 3, 4. This is my M prime. -6, 8 is up here. That's my S. So that's going to be over 6, up 8. Okay. Or sorry, over 8, up 6. Over 8, up 1, 2, 3, 4, 5, 6. That's my S prime. So they have the same distance between them, similar kind of orientations, just changing how they are in relation to one another. On this one, across the line y equals x is going to be this diagonal right here. It's helpful to draw that in, maybe even straighter than I did right there. And you're going to take the x and y values, and you are going to swap them y for x. Okay, so make sure you're looking at it being a reflection across this line like this. So if you turn it on the angle like this, you can kind of see it a little bit better. Again, 8, 4 is over 8 up 1, 2, 3, 4. So the opposite, the switching over y equals x would be over 4 up 8. So it's going to be right here. So this is r prime. Okay. On the next questions, the McDonald's sign, what kind of symmetry does it have? It's the same on both sides of that dotted line there. So that would just be reflectional symmetry. If we rotate it, you can get a W, but it's not really congruent. Triangle sits entirely in quadrant 3. Remember the quadrants are 1, 2, 3, and then 4. So it sits here in quadrant 3. Here's my triangle. If I rotate it 180 degrees, it's going to go 90 here, 180 to here, or 90 to here, 180 to here, depending on which direction. And it's going to look somewhat like this, but it's going to be entirely in quadrant 1. Shape is dilated by a scale factor of 4/5. 4/5 is smaller than 1. So if I said the side of this triangle is 8, and I multiply that by 4/5, that would be 32 divided by 5, which is going to be 6.4. So that's a smaller number. Number 10, true or false, a shape that has been dilated will be congruent to the original shape. Congruent would be exactly the same. And when we're dilating, we're multiplying by a scale factor that 99.9% of the time is not 1. I don't know of an instance when they've actually multiplied by 1, so I'm going to say this one should be false. Number 11, they are congruent. A single rotation will map this one to that one. Well, if I rotate this, I can get it on top of this, but is it going to be perfectly lined up? No. It would be easier for me to turn it like this and then translate it up here to this spot. So that's going to be a false on that one. And then using trigonometry, solve for theta. This is just kind of a throwback to the stuff that we had. We don't have the hypotenuse here. Across from this, here's the opposite. This is the adjacent. So I would be using tangent here. It would be the arctangent because I'm trying to find the angle, and the opposite is 8, the adjacent is 5. So that would be what I type into the calculator. Hopefully this gives you the guidance that you need. If not, make sure to stop by tutorials for help, and good luck on your test.